Hi, this video we're going to look at example of thermodynamics first law, energy conservation. Remember we started with the equation delta E is equal to Q minus W. Okay, and for this example they said average American household consumed 11 to 80 kilowatt hour. So kWh here, that means kilowatt times hour. Kilowatt is a power unit. If you have a power times time, that's going to give us a unit of energy. So this is basically an energy unit. And on the outskirts of a small city, then there's a company that constructed a single large wind turbine. They give us the diameter is 30 and average wind speed is 9 meters per second. Then they're asking, in the perfect energy conversion, which means it's complete 100% conversion, how many households can this one installation serve? So this is a great question. Let's take a look. So what is the increase of the energy? Increase of energy, it's going to be, for this situation, they basically consider the house is gonna completely get this energy from the wind turbine, so it's complete energy conversion. So now we even don't need to use this equation here. We have average household is 11,280 kilowatt hour, and this is one household. And this one wind turbine is, we're gonna see how much energy output is gonna produce, right? Then we know when it's produced this kinetic energy. And kinetic energy is half mv squared. However, we don't know the mass. Do we know the mass? We don't. However, we know the mass, we can maybe define mass flow rate. So it's going to be kinetic energy divided by time. That's basically power. And then if we find power, we're just going to go ahead and figure out the 24 hours, right? So 24 hours a day, and then we figure out this is per year. So then we got to figure out 365 days a year and how much turbine energy produced. So our goal is to find this. Then we'll figure out the time. Then do we have everything we need here? Do we know the mass flow rate? We don't. Do we know the velocity of the blade? We do, which is, for my situation, is 9 meters per second. Then that's 9 squared. Then how do we figure out the mass flow rate then? That's our next step, right? What's our mass flow rate? So you can go ahead and refer to the earlier YouTube video I made I believe it's under physics and engineering fundamental playlist. So here's a quick review. Mass flow rate is mass over time. And mass flow rate can be related to the volume flow rate. It's V, big V, that's the volume flow rate, times the density. Okay, we can quickly evaluate that or verify that. Mass flow rate is kilogram per second. And the volume flow rate, V dot, is how many volume meter cube per second. And density is mass over volume, how many kilogram per meter cube. So they cancel out, so they satisfy each other on both hands. So in order to find the mass flow rate, we need to know the density. And do we know the density of the air? We do, that's a given, so that's good. The ultimate goal is to find a volume flow rate. Now let's think about, how do we find the volume flow rate? Volume flow rate is going to be basically the velocity times cross-section area. Again, that's a concept I talked earlier on in one of the episodes. Volume flow rate is meter cube per second. How many volume per second? Velocity is how many meter per second. Area is meter square. Again, left and right hand have the same dimension. So now get back to this. Do we know the velocity? We do. They said the velocity is 9 meter per second. Area, okay, so it's a circular cross section, right? The blades is making cross so we know the diameter. We can. So knowing that, we can go ahead and figure out this one turbine. The power input is going to be half m dot v square, half 9 square, and m dot. And this m dot is going to be the density of the air times the volume flow rate. So it's the density. Volume flow rate is the velocity, which is 9 meter per second. Area, they give us the diameter, so we can use pi d squared over 4. D is our diameter. Okay, half 9 squared. Our density of this air is 1.25 kilogram per meter cube. Then times 9 again. Then times pi d. Our d is diameter is 30, so 30 square. Or you can use pi r square, right? Pi r square, it's the same as pi d square over 4, right? So then you can go ahead and get this power, and be aware this is going to give you the unit of watt. And since why do we know it's watt? Because every single unit you're using is correct, is the base unit, so you're going to get watt. But we are going to see this is per second. Watt is basically joule per second. In order to figure out this 1 year, how much energy is produced by this one turbine installation during the course of 1 year, then for 1 year, we're going to use this entire value right here. Then we're going to times how many, how many seconds per hour, right? 60 seconds. I'm sorry. 1 hour is 3,600 seconds. 1 hour, 60 minutes. Each minute, 60 seconds. All right. Then we'll see 1 day we'll have 24 hours. Then we say each year, 1 year, will have 365 days. So knowing all of that, we should be able to get entire energy output of this turbine in units of joule, right? And remember, one household for 1 year is kilowatt times hour. Then kilowatt hour we're talking about, it's energy units, kilowatt times hour. So if you want to change that, you can. You should, in order to make it happen. So you're going to change that to, for example, 11,280 kilowatt hour. And that hour is going to be how many seconds? 1 hour is going to be 3,600 seconds per hour, right? And this is hour. So hour and hour canceled out. You will get kilowatt seconds. Then what will you do? You will go ahead and divide this by 1,000. Then you will get watt second. So basically it's joule. In that situation, you have joule and joule here. Well, what do we do at the end? You use this value. If this value is 1, you use 1 to designate this value. This value you got is 2. Then you need to figure out how many number of households. It's basically how much input coming out of this wind turbine during the course of 1 year divided by each one household during the course of 1 year use that much. Then you see how many number. That's going to be our answer for this problem. All right. Hopefully you enjoy working on this problem. I'll see you next time. Bye.